Hello, welcome to this video on moles and calculating molar masses. For this video, you will need a periodic table and a calculator. If you do not have a GCSE periodic table to hand, search for GCSE periodic table on Google. Pause the video now to make sure that you have these items ready. Today, we are going to define a mole, we are going to practice calculating molar masses of substances, and we're going to calculate masses in grams of a given moles of a solid substance. When we make a cake, we must make sure that we have the correct ratio of each ingredient. For example, if we have too many eggs, the cake will be rubbery, too much flour and the cake will be dry, too much butter and the cake will be greasy. This is similar to a chemical reaction. In a chemical reaction, we must also make sure that we have the correct ratio of reactants and products. Have you ever wondered what the big numbers at the front of an atom in a compound mean? These numbers are called coefficients and represent the ideal ratio of each substance needed for the reaction in a chemical equation. A balanced chemical equation has coefficients in front of each number. If there's no coefficient, that's because there is an implied number 1. For instance, oxygen, O2, has 1 mole. These numbers tell us the ideal ratio of moles required in this chemical reaction. For instance, if I have 2 moles of hydrogen, I will produce 2 moles of water. The ratio here is 2 moles of hydrogen will produce 2 moles of water. Because actual masses of atoms, molecules and ions are too small, there would be billions of them in a reaction. It would not make sense to use the actual number of particles involved. For instance, we wouldn't say 7 billion particles of hydrogen are needed to react with 3.5 billion particles of oxygen. This is just too many atoms to think about. For this reason, chemical amounts are given in their own unit or measurement, and we call this a mole. So what is a mole? The mole is a unit. Its symbol is mol, M-O-L. 1 mole is a specific number of things. It's a very big number, in fact. 1 mole is 602 sextillion things. That's 6.02 times 10 to the 23 of something. Therefore, 1 mole is equal to 6.02 times 10 to the 23 of something. The mole is a very large number, and this is because it is used to measure or quantify something that is very small, such as atoms. Let's look at an example to help you imagine what 1 mole of something might look like. If you have 1 basketball, then you have 1 basketball. If you have a mole of basketballs, you have 6.02 times 10 to the 23 basketballs. That would make a pile of basketballs roughly the same volume as the Earth. In this measuring cylinder, there is 1 mole of water, and that means there is 6.02 times 10 to the 23 water molecules. This number also has a name that we need to know. 6.02 times 10 to the 23 is called the Avogadro's constant, which is named after the Italian scientist whose work led to its discovery. And Avogadro's constant is equal to 1 mole of something. When we make products, we still need to know how much to add, i.e. what masses to use in order to make them. So we need to be able to convert these moles into something useful like mass. So what does a mole of atoms look like? As we have said, atoms are really small. So even a mole of carbon atoms is just a small pile of carbon, as you can see from this picture of 1 mole of carbon on the balance. The definition of a mole is 1 mole is the number of atoms in 12 grams of carbon-12. Knowing this actually allows us to do some useful things. It allows us to know roughly how many atoms and molecules are in an amount of something. Carbon has an atomic mass of 12. A mole of carbon has a mass of 12 grams. Hydrogen has an atomic mass of 1, so a mole of hydrogen has a mass of 1 gram. Calcium has an atomic mass of 40, so a mole of calcium has a mass of 40 grams. This is called the molar mass. So the molar mass of 2 moles of carbon would actually be 24 grams, as the mass of 1 mole of carbon is 12 grams. This gives us the following simple formula. Moles is equal to mass divided by mR, and we can rearrange this to work out things such as mass. Let's do a quick check for your understanding before we move on to some further questions. Pause the video and answer the following 6 multiple choice questions. Unpause when you are ready to check your answers. Let's see if you got it right. Notice that number 3 could have 2 possible answers. Okay, we are going to do 3 calculations. The first calculation we're going to practice is finding the AR, relative atomic mass, or MR, relative formula mass, of a compound or an element. Then we're going to look at calculating molar mass, and then we're going to look at calculating the moles of a solid. For these tasks, you will definitely need to make sure you have a periodic table and a calculator ready to use. Pause the video and make sure you have that to hand. Firstly, we're going to use the atomic mass number to work out the AR or MR of these substances below. This is the atomic mass number for sodium. Therefore, the AR of sodium is 23. Copper will also have an atomic mass. This is the atomic mass for copper. It is the larger number of the 2 on the periodic table for each element. Therefore, the AR of copper is 63.5. For water, we do not have an AR. We have an MR, a relative formula mass, because H2O is a formula. For this, we will need to look at the oxygen element and the hydrogen element on the periodic table. In water, there are 2 hydrogen atoms and 1 oxygen atom. So our relative formula mass is equal to 2 times the atomic mass of a hydrogen atom plus 1 times the atomic mass of an oxygen atom, which gives us a relative formula mass of 18 for water. Now use your atomic masses in your periodic table to work out the AR or the MR of the following substances. Pause the video now whilst you do this. Let's check your answers. Did you get it right? Remember that on number 5 we multiply the atoms in the brackets by the small number outside it. Therefore, there are 2 nitrogen atoms in total, and 2 times 4, 8 hydrogen atoms in total for compound number 5, which is ammonium sulfate. Now let's practice molar mass calculations. We're going to use the relative atomic masses on the periodic table to tell us the mass of 1 mole of each element. So, to find the molar mass of 1 mole of an element, we need to look at the atomic mass number in the periodic table. For instance, for lithium, 7 is the atomic mass number. The mass of 1 mole, or the molar mass of lithium, is therefore 7 grams. Now let's take nitrogen gas, which exists as a diatomic molecule, N2. We look at nitrogen as a singular element in the periodic table. We see that the atomic mass of nitrogen is 14. As there are 2 nitrogen atoms in nitrogen gas, we need to times the atomic mass number by 2. This means the molar mass of 1 mole of nitrogen gas is actually 28 grams. Pause the video and work out questions 1 to 3 using your relative atomic mass in your periodic table and your calculator. Remember again that number 3, hydrogen gas, is a diatomic molecule. Let's see if you got it right. Remember, all of these are 1 mole of each substance. Make sure that you don't forget to put grams as your units for your molar mass. Let's move on to our third type of calculation, calculating the moles of a solid. In order to do this calculation, we need to use the equation that we learned earlier, except rearranged as mass is equal to moles times mR, or AR in this case. So, we're going to find the mass of 3 moles of potassium. To do this, we need to use the equation mass equals moles times AR. 3 moles of potassium times the AR of potassium, which is 39, gives us a mass of 3 moles of potassium of 117 grams. Again, do not forget to put the units of grams for these calculations. Let's look at our second example, the mass of 5 moles of boron. Again, we use the equation mass is equal to moles times AR. The number of moles here are 5. The AR of boron is 11, which we find in the atomic number of the periodic table for boron. And the answer here is 55 grams. Now pause the video and have a go at questions 3 to 5 by yourself. Make sure you use the equation mass equals moles times MR, or AR, and that you use your periodic table as well to check the atomic masses. When you're finished, unpause the video and check your answers. Let's check if you got it right. Remember, for each of these questions, your answer must be given with a unit, which in this case is grams. If you have not written a unit for your answer, please make sure you write the unit in now. If you got most of the previous examples correct, pause the video and have a go at the further examples shown here below. Remember to give units where applicable and carefully check your rearrangement of your equation moles equals mass divided by mR. Once you've finished, unpause the video and check your answers. Let's see if you got it correct. Thank you for watching and good luck with your further practice.